Well, hello. So today we're going to be learning about polynomial functions. And the first lesson that I'm going to be doing is lesson 8.1.1. So in this lesson, we will be determining the degree of a polynomial function, which is just stating what degree polynomial it is. You take the highest term degree, and that's your highest degree. It's simple, straightforward. For this one, the highest exponent value that you have is x to the 6th power. Therefore, this is a 6th degree polynomial. And then, if it's factored, you can still find out which degree it is. You don't need to factor each one by one. You have two x's here. If you factor, you get x squared plus 8x plus 16. But we just need the x squared times x cubed, times x to the 4th, and then times x to the 5th. That's why it's a 5th degree polynomial. Simple, straightforward. If you have any questions, let me know when you see me. So, let's do the first problem. The first problem is asking to find the x-intercept, the y-intercept, and the degree of this polynomial. So we're just going to be doing what we've been doing for all the other functions we've seen: quadratic functions, hyperbolas, which is x to the cubed, absolute value, even logarithmic functions, even though, well, we haven't taken the x-intercept or y-intercepts of logarithmic functions. So let's scratch that. Exponential functions, I can't think of any more, but you guys will know more, hopefully. No, probably. So let's start with the first one. X-intercepts. So it's already factored for us. We don't need to do anything else. So x minus 2, to create a 0 for that one, it's just going to be 2. But what is the x value? X has to equal, what is the x value? X has to equal 2. What is the y value? 0, because we're trying to create a 0. So that's our first x-intercept. And if we look here, somewhere around 2, 0. Let's look at the second one. Does it matter if it's squared? No, does not matter. We just need to look at it. Squared tells us something different of what's going to happen to this graph. Hopefully you guys might be able to see it. If you guys do see it, you're good to go. So to get a 0 over there, -5 and 0. That's my second x-intercept. Now the y-intercept, we're gonna figure out what y equals if x equals 0. So it'll be 0 minus 2 times 0 plus 5 squared. So it's 25 times -2, which is -50. So we know that we plugged in 0 for the x, and -50 is our output. All right, now the hard question. What's the degree? X squared, right? Times x gives you x cubed. So it's a 3rd degree. Whoops, forgot the E. 3rd degree polynomial. Simple. You don't need to overthink it. This is what it is. We're going to be continuing in the next few lessons. We're going to be learning how to figure out scale factors and whatnot. You don't need to worry about that right now. All you need to worry about is figure out how to find the x-intercepts and the y-intercepts and the degree. So let's do the second one. If we look at the problem, there's -2 out front, and there's no square. Do you guys see anything between this one and that one? They're both, is this one, what degree is this? Actually, before we jump into that, how about we just find the x-intercepts, y-intercepts, and the degree. So the x-intercept, let's start with x minus 2. Do we need to worry about -2? No, it's on the outside of the parentheses. So x minus 2, how do you get 0 in there? 2. And new output's going to be 0. How do we create a 0 in here? Negative 2. I'm going to put a comma. Negative 2 to get a 0. How do we get a 0 here? 3, comma, 0. All right, how do we find the y-intercept? Y equals negative 2 times 0 minus 2 times 0 plus 2. Well, and 0 minus 3. Hopefully you guys can see that. I hope I didn't try to push it all in together. So we know that x is 0. What's y? Yes, y is going to be negative 24. So you do what's inside the parentheses, multiply everything together, including the negative 2, and you get the negative 24. We can ignore it for the x-intercept because all we're looking at is what's inside each of the parentheses. And it doesn't matter to which degree it is, although we have done x-intercepts for quadratic and hyperbolas. But we can do the same thing for polynomials. Any polynomial to any degree. What's the degree of this? Well, let's see. X times x, x squared, times x, x cubed. How many do you get? 3. So it's a third degree as well. Simple. Okay, bonus question. What's the difference between this one and that one? I'm hoping that some of you guys said, well, this one has an x plus 5 squared. This one has 3 different root values. What does the x plus 5 squared do in comparison to this graph? It only touches the x-axis. It doesn't cross through the x-axis. Here, it crosses through it 1, 2, 3 times. That's why we know it's a third degree. But we can't say it's a third degree because sometimes it won't cross through it. But we can tell a different way to tell if it's a third degree polynomial, like the amount of times it changes directions. So it goes one direction, 1, then it switches, goes down, 2, then it goes back up, 3. Third degree. Same thing here, 1, 2, 3. So you can do it both ways, but it's easier to look at what the degree polynomial. If you are given a graph, you can check your answer and be like, oh, 1, 2, 3. I'm right. It is a third degree polynomial. The more tools you have, the better, right? I'm getting better at talking to myself. Might be the insanity talking. Who knows? All right. So let's do number 3. Like I said in the previous videos, if you want, you guys can do these before I do them. Just pause the video. Same thing. Should have said it earlier, but, you know, these are the harder ones. So if you could do these, you could do any of them. So let's do the x-intercepts for this one. Do we need to worry about 2x plus 3? Can we still find a 0 for that? The answer is yes. Yes, we still can. So, x minus 2. To get a 0, I just need a 2, 0. And if we need 2x plus 3, I can set 2x plus 3 equals 0 and solve for x. That's another way of doing it. So I can get 2x equals negative 3, x equals negative 3 over 2. So if I plug in negative 3 over 2, I should get a 0 within that one. So I'll do negative 3 over 2, 0. And now, x plus 4. Negative 4, 0. X plus 1. Negative 1, 0. Now let's do the y-intercept. Since, you know, I've already written, just plug in a 0 for all the x values. I'll do it here. I'll do it down here. Since I used this to find the x-intercept for 2x plus 3. So 2 times 0 plus 3. And you guys all know what 2 times 0 is. You guys could do this in your head. I wouldn't recommend it, but you could. And the reason I'm saying I wouldn't recommend it is because there's a lot of numbers to keep track of, and that's kind of hard to do in your head. So just take it step by step. You can skip a few steps if you feel like it. Do it your way, except for, all in one go. That's hard, even for me. I have the answers next to me. That's why it seems like I'm doing it all in my head. So I got 0, -24 for that answer. All right, now the more difficult one. Degree. What is the degree of this polynomial? Well, x times 2x, 2x squared times x, 2x to the third times x, 2x to the fourth. So we don't need to worry about the 2 in front. But what is that x to the power of? 4. So we get 4th degree polynomial. And then if we want to check on the graph, 1, change direction, 2, change direction, 3, change direction, 4. So I'm correct. Good to go. So let's do number 3. Do I need a factor number 3? Look at it. Look at the graph. Hint, hint. Do I need to factor the function? The answer is no. I'm given the x-intercepts, and I'm also given the y-intercept. The y-intercept could also be the x-intercept, as shown here. So, -3, 0, 0, 0, 3, 0. Right there. Y-intercept only crosses once at 0, 0. Now what's my degree? We can look at the function or we can look at the graph. Your choice. For me, it's easier to look at the function. X to the power 4. That's my highest degree. So it's going to be 4th degree polynomial. I'm good to go. I realize that some of you guys might have questions such as, could I just write 4 or 3 or 2 or 10? Yeah, if I asked you for a degree and I read it in this way, you could write 4. Degree 4. Yeah, perfect. I'm just writing it this way because I want to make sure that you guys understand that it's 4th degree, not just 4. Even though that the degree is over there, but if I tell you, give me the degree without giving you anything like that, you're going to write 4th degree. But if you write 4 degree dot dot 4, then I'll know what you mean. All right, let's do the second page of 8.1.1. We're not done. So, there's a YouTube video. There's a link to a YouTube video on this page. Watch it. If you have any questions, don't understand degrees, don't understand the behaviors of a polynomial function, it's a very good video. It will give you all of that. It will help you through this in case my explanations are a bit confusing or simplistic, or you want a little bit more. Go for it. Watch the video. But let's look at this chart. So, you notice how the leading coefficients are either positive or negative, right? And positive or negative. And then you have a degree, whether it's even or odd. Well, this tells you the end behaviors. If you have a positive leading coefficient and an even degree, you get an end behavior of up, up. So, if we look back onto the sheet that we just finished, if we look at number 3, we have a positive degree and a positive leading coefficient, because if we factor it out, we get positive 2x to the 4th. So, the end behavior on the left end behavior, right here, goes up positively, and the right end behavior goes up positively. That's what it's saying. the end behaviors tell you what's happening. So if we look at the odd, hopefully this will be... So if we look at negative and odd, it goes up on the left end, and then on the right end, it goes down. Is that true? Well, number 2 has those words. Words are hard. I'm losing it. Has those conditions. Yes, sometimes we do have those moments. So, number 2 has those conditions. Negative, leading coefficient, and third, an odd degree. Does it go up on the left-hand side? It does. It's going up. On the right-hand side, is it going down? Yes. But what else do we notice for the end behaviors? Give you a moment. Maybe you'll get very good at talking to yourself like me. So, if it's a even degree, it'll either be up, up, or down, down. If it's an odd degree, you'll get down, up, or up, down. You'll get the opposite happening on both ends. So you can immediately see which one's even, which one's odd, before you even look at anything else. If you look at the graph, you could tell if they have odd end behaviors. If they have, opposite end behaviors, they're odd. If they have the same end behaviors, then they're even. Wish you guys can see my hand movements. Kidding. Nobody wants to see those. I just look like a madman. Kidding. Kidding. So let's determine the degree and behavior for the following functions. So fifth, what's the highest degree? Fifth. So we get fifth degree. What's the end behavior? It's going to be, I'll do a semicolon. It's going to be up, up, down, 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 up, down. Well, we know it's odd, so it's going to be opposite. But is it positive leading coefficient? It is. So if we look here, down, up, down, try to fix the capital. Oh well, your choice. All right, let's do number 2. Well, hopefully you guys did it ahead of time, and you're probably screaming at me to hurry up, which is a good sign. All right, let's begin. Is it even or odd? Well, you don't know that off the bat. You'll have to multiply them through. Well, you don't need to multiply to figure out the entire function like above. You just need to know what the leading coefficient is. But you do know that the leading coefficient is going to be negative. Negative out front. All of the x's are positive. It's going to be negative. X squared times x, x cubed times x, x to the 4th. So it's going to be an odd 4th degree. I'm hoping that this part is the least confusing part for you guys. If you have any questions, ask me, ask Mrs. Marshall. So, when we come back, when we meet up online. All right. So what is the end behavior? We have the leading coefficient and we have the degree. You're right. 4th degree, even, negative, down, down. All right, let's do this one. Determine the degree and x and y intercepts of each polynomial function and draw a sketch of the graph. So I want to start out by finding the x and y intercepts. I don't think you guys can see the entire paper on screen. Let me zoom out. There we go. All right. So I want to start by finding the x and y intercepts and the degree. So I'll make it easier for me to draw the graph. X-intercepts. X plus 10, how do we get a negative? Negative 10, 0. X plus 7, negative 7, 0. But x minus 12, positive 12, 0. Easy. Now let's do the y-intercept. So I'll do it like I did down here. P of x, whoops. P of x equals, just making sure that you guys can see it, equals 0 plus 10 times 0 plus 7 times 0 minus 12. What do we get? We get, well, first the x value is 0, and we get negative 840. Yay! We get to plot it at 0, negative 840. But we're not done. We have to find the degree. X times x times x gives us x cubed. So it's third degree, or you can leave it as 3. Your choice. Degree 3. Yeah, we're good to go. So I'm just going to write arbitrary. I'm going to put in these points, negative 10, 0, negative 7, 0, and 12, 0. So if I start with negative 10, somewhere over there, negative 7, somewhere over there, and 12, somewhere way out there. So I know that all three of these intercepts cross through the x-axis because there's no squared. From what I picked up from the previous page. Right? From this page. I remember. So we don't know at 0, negative 840 if it creates a minimum or if it just crosses through. So we don't need to really worry about that because it's just a sketch to see what we might think it looks like. And yes, you could check through Desmos and cheat and be all like, well, you know, it just crosses through there and it doesn't really hit it. Honestly, there we go. Hopefully I made some people happy. And we get something like that. It's not going to look exactly like it because I made an arbitrary point down there. This point would be way, way, way below the page. And it'd be a lot more skinnier. But you don't need to worry about that. This is just a sketch. I'm not going to mark you down or anything if it's not exact, if I'm asking for a sketch. You will know later how to make an exact graph, but for now, this is good enough. So let's do the second one. Try it before I do it. And here's the double root. Here's a little hint on the double root for graphing. See, you guys already knew what was happening in the other one. You guys recognized it, recognized the pattern. And this is telling you. I'm not going to read the whole thing. You guys can read that on your own. If it occurs twice, the graph does not pass through the x-axis. What you guys figured out in the last page. You guys are good to go. So let's find the x-intercepts, the y-intercept, and the degree of this function. So let's start out with the x-intercepts. Sorry. Oh, I forgot to mention of the last one. Sorry, I'm going back a little. I knew that it started out from the negative because I looked at the table up here, right? It's an odd, but it has positive. So it starts from down, then it goes up. Left end is down, right end is up. That's how I knew. So we're going to be using this table to figure out these ends before we draw what the function should look like. And how many turns we're going to make? Well, we know that from the degree. Sorry for mentioning that, I forgot. But let's do number 2. X-intercepts. So x plus 7, how do I get a 0 in there? Negative 7, 0, yep. How do we get a 0 of x minus 7? 7, which gives us a 0. So now, how do we find the y-intercept? So w of x equals negative times 0 plus 7 squared times 0 minus 7 squared. And if we multiply that out, we will get 0, negative 2,401. Big number. Don't worry. You don't need to go all the way down onto your table to graph this. You can if you want to. I'm not going to say no, but you don't need to. So let's start out with 0, negative 2,401. Yes, I should be labeling my points. Forgot. I was going to do it after I graphed it so my points don't interfere, but I will do them right now since I already know how I'm going to sketch them. And then over here, let's just say it's right about here. 7, negative 7's right there. So since I can't cross over the x-axis for both of them because they're squared, I know they're going to stay below the x-axis. So negative 7, 0, 7, 0. So now we got to know, what's the leading coefficient? Negative. Is it even or odd? It's even, so it's going to be down, down. So it's going to start going down and it's going to end going down. So let's graph it. Whoops. Down, then we come back. We only touch it, we don't cross. Going over, because it's so even on both sides, I'm going to assume that this is going to be the minimum of this part of the polynomial. Come back up. Touches, doesn't cross into the x-axis, and comes back down. And that is the graph. Fine, I'll label the other one negative 10, 0, negative 7, 0, and 12, 0. And down here, it's 0, negative 840. Perfect. We are done. If you have any questions, ask me when we get back. I hope this helped. I hope that I wasn't too confusing. And yeah, if you guys have any questions or if you want me to change anything when I'm doing these, please let me know when you see me online. Thank you.